This is the parameter analysis tab of SN Design. And what we have here is we have a dynamic model that took the search parameters and then fits a multi-dimensional surface through there. So we can see what happens to the cost and the factor of safety as the wall height changes. You can watch the scroll bars move as you move to a specific wall height. You can see what is the cost at that height and what is the factor of safety of that height. However, we can view that graphically by moving down. You can see that as the wall height increases, the cost of the wall increases. And now what happens whenever we change the wall batter angle? We can see that the relationship between the wall height and the wall cost, the wall height and the cost and the wall height and the factor of safety both change. And we can plot that graphically and show in 2D whenever we have a low wall height and a low wall face, low wall batter angle. And now what we're doing is we're changing the length of the nail, and you can see that the relationship between wall height and wall theta and cost changes based on the length of the nail. This is multi-dimensional. Now we'll look at the factor of safety. Now we'll look and see how the nail length compares to, say, the nail inclination angle. Okay, there's a nail inclination angle. Let's plot both of them. Now I'll rotate this around so you can see the relationship between the nail length and the nail theta angle. See that the factor of safety seems to go, move this up a little bit, the factor of safety seems to increase up to a length of about 50 feet, and then the factor of safety goes down. And you can see that a lower batter angle has a slightly higher factor of safety than a middle one in this case. And we can see if we increase the height of the wall, how does the nail length and theta adjust. However, a more useful application is that our height of our wall, we want to be like 25 or 26, not 25.2. Or our wall batter angle, we want it to be either 5 or 6. We don't want it to be 5.3. So what we can do is we can adjust the wall batter angle to 5 and then to 6, and then look at the cost and the factor of safety and see, is it better to round up or better to round down? And this is just a very quick and convenient way of using standard sizes for nail lengths, a standard vertical spacing or horizontal spacing, and standard inclination angle. And later, if we designed, if we included bar sizes, we could put in a standard bar size. And this just allows us to adjust these parameters to find whether we should round up or round down without having to guess as to what would be the effect on the factor of safety or the cost.